Welcome, ladies and gentlemen. So what I'd like to do is show you how to determine all of the solutions of a polynomial when given a factor, a zero, or a root. So the main important thing is we need to understand, well, what exactly is the difference between a factor, a zero, and a root? Well, basically they're all very similar, and they're all related to each other, and they all are going to help us determine all of the solutions. And actually, the zero and the root are actually already two solutions of a polynomial. That means they're x-intercept. They're where the graph crosses the x-axis. So those are actually already two solutions. But they want us to find all of the solutions. So then what exactly is a factor? Well, a factor, remember, is basically an expression or a term that is going to evenly divide into another expression or term. For instance, let's use something simple. Let's say 2 is a factor of 12, right? Does 2 divide into 12? Yes. So 2 is a factor. So since we know that x plus 1 is a factor of x cubed minus 4x squared plus x plus 6, we know that x plus 1 evenly divides into that polynomial. So we can show that to find the quotient, and then maybe we might be able to work our way a little bit down. Since I know that my factor is a linear binomial, I am going to use synthetic division to divide, because I don't like to use long division unless I have to. Now, one of the things I talked about when using synthetic division was always setting your divisor equal to 0. And the reason being is because your factor, when you set your factor equal to 0, what you are actually solving for is the 0 or the root. You're actually solving for one of the solutions. And why is that the case? Well, go back to quadratic equations. When we were factoring to solve for quadratic equations, you had a quadratic. And then what we did is we factored it into two binomials or two expressions. And then you used the zero product property to set them both equal to 0. So when you had your factors, you set them equal to 0 to find the solutions. So when I take a factor, I set it equal to 0, I solve. Now I have a 0. Or if this was an equation, I would have a root. But this is one of my solutions. And that's actually what you use when using the synthetic division. You actually use one of the zeros. So therefore, now I set up my synthetic division. I take my 0 from my factor or divisor. I put that outside of my little box. Then I take the coefficients of each of my terms here. That's -1. I'm sorry, that's +1. That's +1. Just make sure you include them. It's also in descending order, and I'm not missing any terms. So I'm just going to go in order here. I have 1, -4, +1, and 6. So remember the algorithm for synthetic division here. First term we're going to bring down. That's 1. 1 times -1 is -1. -5 plus -1 is -5. -5 times -1 is +5. 1 plus 5 is 6. 6 times -1 is -6. 6 plus -6 is 0. So that is our quotient. But remember, our quotient is going to represent a polynomial here. Because think about it. When we said 2 was a factor of 12, right, it divides into there. Well, how many times does it divide into there? It divides into there 6 times, right? So remember, if you say 2 divides into 12 6 times, you can also say 6 times 2 equals 12. Whatever your quotient is times your divisor is going to give you back your dividend or your original problem. So x plus 1 divides into this how many times? So what we're going to do is we're going to want to rewrite this. So basically, we could say, well, actually, let me get to this here in a second. So that's our remainder. It evenly divides. That's our constant, our linear, and our quadratic term. So basically, I can rewrite this now as the product of two factors. Just like I did the 2 divides into 12 is this 6 times, the same thing as 6 times 2 equals 12. I can now say that, let's see, x plus 1. Well, let's do that in blue. X plus 1 times x squared minus 5x plus 6. Now, this times this gives you that. Now, again, what we're trying to do is we're trying to find all the solutions. So I set this factor equal to 0 to find the 0. And that was easy. So I want to set now this, both of these all equal to 0 so I can solve. But here I have a quadratic. I need to further factor this down. Well, fortunately, I see that I can factor this into x. Let's see. What two numbers multiply to give me 6, add to give me -5? So that's going to be -3 and x plus, x minus 3 and x minus 2. Then I can apply the zero product property. So now what I have done here is I have rewritten my polynomial as a product of its linear factors. Then I can set them all equal to 0. which I already did for the blue, but. OK, and then I can say x equals -1, x equals +3, and x equals 2. So therefore, ladies and gentlemen, we have our 3 solutions, and we are all good to go. So what happens when we have a 0? Well, a 0 is already a part of the solution. They're just asking us to find all of the solutions. So just like when we had a factor, I had to set it equal to 0 to solve to find one of the zeros. Now, they already give us a 0. So giving us -2 is like already showing us that then there is going to be -1. So what I'm going to do is just start my synthetic division. Take the coefficients, make sure that it's in descending order, make sure you're not missing any terms, which in this case we're not. So I'm going to do 2, -3, -11, and 6. First things first, bring down the 2. 2 times -2 is -4. -3 times -4, or sorry, -3 plus -4 is a -7. -7 times -2 is a +14. -11 plus 14 is going to be a +3. 3 times -2 is -6. Add them up, you get a 0. So here's my remainder, constant, linear, quadratic. Now this one becomes a little bit difficult here because, well, what is if -2 is a 0? How can I rewrite that as a factor? Well, remember, all we did to go from factor to 0 is we took our factor, set it equal to 0. So if I tell you x equals -2 is a 0, then x plus 2 is going to be your factor. OK? So you can kind of like set it back equal to x and then get it on one side. So that's going to be your factor. So basically what that's telling me is x plus 2 times now this polynomial, 2x squared minus 7x plus 3. This times this gives you back our polynomial. But again, we want to find all the solutions, so we're going to set it equal to 0. Now, I already set this one equal to 0, so I want to see, can I further factor this? Because sometimes it's not going to be factorable. You're going to have to use quadratic formula or completing the square. However, in this one, when I go and look to factor it here, I have 2x and x. What I see is if I use the numbers, let's see, which will multiply to give me -3. 2x times x gives you 2x squared. -1 times -3 gives you +3. And then my middle terms and outer terms add up to give me -7. So this works. So now once I write my polynomial as a product of its linear factors, I set everything equal to 0. Now, I already know x plus 2 equals 0. We already know that's the 0, x equals -2. But I have 2x minus 1 equals 0, and x minus 3 equals 0. Again, I'm setting them equal to 0 by applying the 0 product property. I've rewritten them as a product of their linear factors. So now I have my solutions as x equals -2, x equals 1/2, and x equals 3. OK? Ta-da. All right, let's get into the last one. The last one is basically the same. It's just using a different level of vocabulary. And we have a fraction, which nobody likes. So to understand the difference between a root and a 0 is basically we talk about the solutions as the roots of an equation and the solutions as zeros of a function. But basically, they're meaning the exact same thing. So basically, if this is going to be my root, we're going to treat it just like we did as it's 0. OK? Whereas a factor is something totally different. Factor tells you that it divides into it. You always set your factor equal to 0 to solve for the solution or the root. So in this case, though, we know that we can immediately set up synthetic division, since they're telling us that is our root. And we have a polynomial that we'll set up. OK, so again, it's in descending order. I'm not missing any terms. So I write down the coefficients, 3, 7, -22, -8. All right, now let's go and follow the process. I know it's a fraction, but that's OK. First thing, bring down the 3. 3 times -3 is going to be a -1. 7 plus -1 is going to be a +6. +6 times -1/3 is going to be a -2. -22 plus -2 is going to be a -24. -24 times -1/3 is going to be a +8. That gives us a 0. Now, just like I did over here, this one gets students a lot. If x equals -1/3 if that is a root, what is the factor? Well, we don't want to write our factors with fractions. So writing x plus 1/3 equals 0 is not really going to work. Okay? We don't want to write our factors with fractions. We always want to write them with our integers. So to do that, what I can do here is I can use inverse operations. I can multiply by -3. Actually, let's leave that. I'll multiply by +3. So now I'm left with 3x equals -1. Then I'll add 1 to both sides, and I have 3x plus 1 equals 0. Or 3x plus 1 is going to be the factor. Okay? So always use your inverse operations when you want to convert a root or a 0 to a factor. So basically, we have one factor, which we were given, 3x plus 1. We weren't given the factor. We were given the root, but we converted it to a root. And then we're given 3x plus 3x squared plus 6x minus 24. And then again, we want to solve all of the solutions, so we're going to set that equal to 0. So again, ladies and gentlemen, we got to see, can we factor this, right? So we're going to want to break this apart to 3x and 2x. Well, let's see here. We want our two numbers. They need to, let's see, they're going to give us a -24. So I'm thinking 12 and 2 and multiply that by 6. So let's see here. That would be, let's do +12, -2. All right, let's see if this works. 3x times x is 3x squared. 12 times -2 is -24. And then as long as my middle terms add to +6x. 12x times x is 12x. 3x times -2 is -6x. 12x plus -6x is 6x. So this works. So please make sure you remember your factoring skills to go through this. I'm not going to work through. I have other videos explaining how to factor. But I just want to make sure you're at it. So now we have that's a factor, and then this other factor that we were given from our root. So now, again, they're asking us to find all of the solutions, right? We're just given a root, find all of the solutions. Well, so therefore, we set them all equal to 0. I really don't need to set this equal to 0 because I already know what the root is. X equals -1/3. However, for the rest of these, I'm going to set them equal to 0. And if I subtract 12 and then divide by 3, I get x equals -4. Add 2, x equals +2. So there you go, ladies and gentlemen. That is how you solve for all of the solutions when given a polynomial and a 0, a root, or a factor. Thanks.